Slab is created using the Slab tool. In the Slab properties, click on Type drop-down menu, to expose all the slab types. Slab type 1 to 12 relates specifically to table 3.14 in the BS 8110. This table is used for design of slab reinforcement, based on the coefficient method or yield line method. Type 1 to 12 does not affect the slab load calculation on the supporting beams. So, don't bother about this during modeling, and leave it as default type 1, for all slabs. There is a function to automatically set the correct type for each slab, if you wish to use this moment coefficient method to design the slab later. One-way slab is a special type of slab. The slab load will be transferred to the two supporting beams only, in the direction of the span, versus load transfer to all supporting beams, for type 1 slab. One example of one-way slab is precast slab. The direction of one-way span must be specified in the angle input box. We will now explore slab creation. Go to Building Setout tab, click Slab Additional Loads. The Slab Additional Loads library is used to create or edit the additional dead loads, which are selectable from the drop-down menu, in the Slab Properties dialog. As you can see, there are currently 3 preset Slab Additional Loads type. Select Room in the right table shows the load or material layers. The material layers can be changed by clicking on the drop-down menu. To review, edit or add material, click on Edit Material. In the Material dialog, you can edit unit weight by clicking on the input. You can also add, or delete a material. Click Cancel. You can change the layer thickness. The load value is calculated by multiplying the unit weight and thickness. The total load is shown at the bottom. Click Edit Load References. This can use to edit the load references of the slab additional dead load of the selected stories. The slab additional dead load with the same group as the selected source load group, can be replaced by the load as specified in the target load group. If Apply Selected Load to All Slabs is checked, the target load will be applied to all slabs in the selected stories. Click Cancel to exit this dialog without any changes. To add a load type, click on Add New Load at the bottom. New load will be added. Rename it, say, Roof. Select a desired color. Click Add New Layer, at the bottom. Select Material Cement Grout. Under Thickness enter 30 mm and press Enter. The total load is auto-calculated. Click OK to save changes and exit. Go to the Modeling tab, and click on the slab icon. In the slab properties, enter the slab thickness, h equals 200 mm. Relative level. By default, 0 means the top of the slab is at the top of the floor level. A positive value will raise the slab. A negative value will lower the slab. Concrete cover. Enter a value of 30 mm. Label position. These icons switches on the slab label, and controls the position of the slab label on plan view. Insertion. By default, the slab insertion is beam region, which means the boundary of the slabs are enclosed by beams. The other options can used if there are no beams. Go to the Loads tab. Under Service Dead Load, you can click on the drop-down menu, and choose the load that was set up in the Slab Additional Loads library. Alternatively, use the default enter value option. Enter service dead load equals 1.2 kN per meter square. Imposed load. If you right-click, you can select preset values, which are obtained from the selected loading code. Alternatively, enter the value directly. Enter or select the value 1.5 kN per meter square. Slab does not contribute to floor diaphragm. By default, this option is unchecked. This means this slab, together with all other connected slabs with this same option, will be converted to floor diaphragm in the analysis. All members that are constrained within the floor diaphragm will move and deflect as a single entity. Hence, the beams connected to this slab cannot lengthen, shorten, nor bend within the floor diaphragm. As a result, the beams will not have axial tension or compression, no minor bending and no minor shear. Place the cursor over at the lower left region bounded by beams. A preview of the slab will be shown. Left click. The first slab will be inserted. The yield line shows the tributary area load, which is automatically calculated onto the supporting beams. This is default method of slab load calculation onto beams. Create 2 more slabs between axis A and B. Change the imposed load to 2 kilonewtons per meter square. Create 4 slabs between axis B and C. Now, change the imposed load to 2.5. Create 3 slabs between axis C and D. Close the slab properties. Check the structure tree. There should be a total of 10 slabs. We will now insert some cantilever slabs. Zoom to the top right part of the model. Cantilever slabs can be inserted by setting type 12 in the slab property. Click on slab icon. Under type, choose type 12. Go to cantilever tab. Enter length of cantilever equals 1000. Pick first intersection of axis to define start of cantilever. Pick second point to define end of cantilever. Move cursor to the side where it is to be inserted. A gray preview will be shown. Pick third point to confirm and insert the cantilever. The cantilever slab is created. Now, repeat the same steps to insert cantilever slab between axis 3 and 4. Notice the edges will join automatically with the adjacent cantilever. To insert a cantilever slab that does not span the entire length of the beam, we must enter values of D and B slab in the cantilever slab properties, as shown in this picture. Enter D equals 1000 mm. Enter B slab equals 2000 mm. Pick first intersection of axis to define start of cantilever at grid 2. Pick second point to define end of cantilever at grid 3. Move cursor to the side where it is to be inserted. Pick the third point to confirm and insert the cantilever. Close the slab properties. We have used type 12 slab to model a regular rectangular cantilever slab. For irregular shaped slabs, you can make use of the polyline slab edge function. Zoom to the top left of the model along the diagonal beam. Click polyline icon. For this function, you need to left-click continuously, to draw the shape of the edge of the slab. First, click exactly on the insertion point of the diagonal beam, which is also the insertion point of the column. Then click on the second point. To change from line to arc, press A on the keyboard. Move the mouse cursor. Then continue to click on the next point. To change to line, press L key. To cancel the last point, press Escape key. You can also press F2 to manually input the next point. Now, try to draw any shape that you like. For the last point, click exactly on the end insertion point of the beam. Move your cursor away and check the point is selected correctly. Right-click and pick Finish, to end the insertion. The slab edge line will be drawn. Click on the slab icon. Ensure type equals 1 is selected. Click anywhere within the slab edge line and a new slab will be created, following the polyline slab edge. Close the slab properties. We will now create a slab opening. Tile the 2D and 3D view vertically. Zoom into the lower left slab, for both the 2D, as well as the 3D view. Go to the Modeling tab. Click the slab opening / drop icon. The slab opening properties dialog box will appear. By default, it will be a rectangular opening. Define the slab opening horizontal length, B1 equals 1000 mm, and vertical length, B2 equals 500 mm. Pick the reference point of the slab opening. Usually the intersection of axis at the lower left corner of slab is recommended. Pick the intersection of axis A and 1 as reference point of insertion. You can then pick any point to insert the slab opening. Alternative, press F2 to manually define the relative coordinates. Enter 1000 mm, 1000 mm, for delta x, and delta y respective. Press Enter and the slab opening will be created. You can rotate the opening using entering an angle. The angle is measured horizontal, anti-clockwise. Drop definition. Instead of an opening, this allows you to change it to a localized drop. Check this option. Under drop, enter -50 mm, which means this part of the slab is lowered by 50 mm. Fill load allows you to enter additional dead load for this drop region. Left-click on another location to insert this slab drop. Check and review the 3D view. Under type, there are other options. Let's try circular and input any parameters that you want. Click anywhere to insert it. Under type, choose polyline. For polyline, you can create an opening of any shape by left-clicking continuously. Click on the first point to start, second point and continue. To change from line to arc, press A on the keyboard. Move the mouse cursor. Click the next point. To change to line, press L key. To cancel the last point, press Escape key. You can also press F2 to manually input the next point. Now, try to draw any shape that you like. To complete, simply click on the first point, to form a close shape. The polyline opening will be created. Close the slab properties. Delete all the other openings, except for the rectangular opening.